Thank you very much for joining today and listening to our presentation. It's great to be able to continue with 2020's Meet the Members this year. My name's Kim West. I'm the Communications Manager for ReNew ELP. Now, we're an innovative plastic recycling solution that we're currently in development at Wilton. So with this morning's presentation, I'm going to give you an overview of why we need this technology, a look at the process, and also the environmental factors and benefits for the wider Teesside area as well. So I'm going to start with some rather sobering facts. So as you can see, annually, production of plastic across the world is at 350 million tonnes. That's every year. And within the next 20 years, by 2040, that plastic production is almost doubling, up at 600 million tonnes per year. Only 14% of that is actually collected for recycling. That's the current global manufacture rate. Only 14% of that is actually collected for recycling. Now, I'll actually just point out there that's only plastic packaging. And just because it's collected doesn't mean it is actually recycled. So the numbers for collection and recycling are pretty low. And approximately 8 million tonnes of plastic is entering the world's oceans every year. I think it breaks down to something like a dumper truck into the ocean every day. The stats are mind-boggling, really. And as we know from extensive media coverage, this plastic is breaking down into microplastics, which then enters the food chain, affecting wildlife, the environment, and ultimately human health as well. So now we're going to look at plastic as a resource. So plastic really has been demonised within the media. The general view is that plastic is both a pollutant and a waste product. But it is in fact a flexible, useful material that's brought about huge changes in medical and food industries. So the plastic problem is not plastic per se, it's more poor management of it. ReNew ELP see plastic as a resource. But as you can see here, a number of plastics, including flexible multi-layer films and also pots, tubs and trays. So we're talking frozen food bags, yogurt pots, ready meal trays. They're actually considered unrecyclable and their destination is landfill or incineration. And of course, that then leads to environmental leakage. With traditional mechanical recycling, which is a current practice in use within the UK, generally plastic is melted and reformed. That's sort of to really break down the process and put it very simply. Now that's applicable only to some plastic types, and generally once plastic has gone through that process, it actually loses its beneficial properties. So it actually creates a lesser quality product at the other side. By relying solely on mechanical recycling, the opportunity for capturing that value, which as you can see at the top is outlined at around $80 billion per year, that opportunity for capturing the value is lost. So we do need additional technologies to capture that and bring more all plastics back into a full recycling loop. Now, what is chemical or advanced recycling? Now, within the industry, it tends to be referred to as chemical recycling, although it is also considered advanced recycling as well. Now, unfortunately, chemical recycling at the moment is not actually defined by any EU regulation, which is something that we're lobbying to change. So Chemical Recycling Europe, which is an association that we are part of, have created the following definition. Any reprocessing technology that directly affects either the formulation of the polymeric waste or the polymer itself, and importantly, converts them into chemical substances, either for the original or alternative purposes. Now, vitally, it's important to note that if a fuel is being produced, that is not classed as recycling. That's termed as recovery. It must produce a product that can be an end product, a recycler that can be reused in new products to be classed as recycling. Now, chemical recycling with Cat-HTR, that is what ReNew ELP are developing at Wilton. So the process, Cat-HTR, is a hydrothermal liquefaction or upgrading technology. And we use something called supercritical water. Now, supercritical water means that it exhibits both the properties of a liquid and a gas, so it can heat like a liquid or it can pass through something like a gas. We use that to convert plastics into shorter chain stable hydrocarbons for reuse in the feedstocks that go into the manufacture of new plastics and other materials. So supercritical water gives us an organic solvent. It gives us a source of hydrogen which completes the broken bonds. That means we don't need to bring in external hydrogen. It also allows us direct heat transfer. So that means that within the reaction, converting the plastic into hydrocarbons, the full plastic mix is converting at the same time, so we don't get excessive cracking or charring. And that also means that we're able to scale the process up as well. And as you can see at the bottom there, typically around 85% of the plastic that we are putting through the Cat-HTR system is being converted into liquid hydrocarbon products. Now, to give you a brief run through of the actual process itself. So we take the waste plastic and we have a front-end sorting facility at the beginning of the process. Now, that is shredding the plastic. It's removing any contaminants such as grit, soil, stones, that kind of thing, and glass. Now, we are able to take levels of organic contamination, so any food that's on the plastic or any paper, so such as labels, we are able to run those through the process. They actually convert into a process gas, which we use to fuel the supercritical boiler. Now, after the plastic waste has been shredded, we melt it and it's put under pressure and then mixed with the supercritical steam that's injected in. It then goes into the Cat-HTR reactor, which is where all the magic happens. That process, once it's in the reactor, it actually takes only around 20 to 25 minutes. So it is a very quick process. The pressure is then brought down and the mix is run through a distillation column. And that is where it splits out into 4 separate products, 4 saleable products, which we can either ship or store. Now, looking at our feedstock materials, we are able to recycle any plastic, and that is the real benefit of chemical recycling, of Cat-HTR specifically. We're focusing on polyolefins, but we can take all plastic types, 1 through 7. Our feedstock is primarily post-consumer plastic packaging. So that's anything coming through a household, any type of plastic, frozen pea bags or ready meal trays, that kind of thing. All the things that you wonder, can I recycle this? Can it go into my recycling? That's the ideal feedstock that we want. So we are also able to take agricultural and commercial waste as well, which the option for all of these plastic streams currently is to be sent to incineration or to landfill. And as we know, that is what is resulting in environmental plastic pollution. Now, the site itself, ReNew ELP, we are actually developing the world's first commercial scale Cat-HTR site. There is a pilot facility in New South Wales in Australia, which we've been able to trial through. But we are developing the world's first commercial scale. So on completion, we'll be recycling 80,000 tonnes per year, and that is made up of 4 20,000-tonne lines. So our plan is to develop the first line, so that will commence construction early next year, and following its build and optimization, we will then roll out the additional 3 lines as well. So starting with the first line very early next year. And we had some really exciting news earlier this year that we were allowed to announce in October. We were actually awarded a £4.42 million grant from Innovate UK, the UK's innovation agency. And that came through the Smart Sustainable Plastic Packaging Programme. So that reflects our drive to recycle post-consumer plastic waste. And that recognises at government level really the potential of this amazing technology to help the government reach their plastic recycling targets. So the project has been underway for a while now, but we are commencing construction early next year. Now, this is an overview of the site. The section in the middle, the gold tower that you can see in the middle of the image there, that is actually where the conversion of plastic to hydrocarbon feedstocks is taking place. So you can see it's actually quite a small section of the whole site. The big green building to the left, that is where we're doing the sorting of the plastic. So that is where the plastic is chopped up, it's shredded, the solid contaminants like grit and stones and glass is removed. So that's taking up the bulk of the process. And then you can see the gold tower in the middle, which is where the Cat-HTR reactors are. And then to the right-hand side of that, the distillation columns where the main mix is split into the 4 separate products that we will be selling. And then you can see storage at the end of the site there on the right-hand side of the image. So we are making 4 hydrocarbon products, 4 saleable products, all that will go back within the petrochemical industry. So looking at the left-hand side of the image here, the lighter, clearer looking products, that is naphtha. So that is the feedstock that goes back into the production of new plastic. We then also produce a distillate gas oil. Again, that can go back into the development of new plastic. Can also be used as an industrial solvent. We produce a heavy gas oil and also a heavy wax residue, which is a real tarry looking substance to the right hand side of the image. That is a product. That product is where all of the fillers and additives of plastic fall into. So within plastic, there are a lot of additives such as colours, that kind of thing, and that is where those additives fall into. And that product can be used as sort of like a bitumen type product. So it can be used within the roofing industry and the road industry as well. And we're currently registering under REACH, which will allow us to export these products into the EU. Now, there are some really great benefits of the Cat-HTR technology. And the key benefit really is the ability to be able to recycle multi-layer and flexible plastic materials, such as those films, those food bags, pots, tubs and trays. Now, currently, these cannot be recycled through traditional mechanical recycling. As mentioned previously, this is the type of plastic that we're focusing on. That's the type of plastic that is going to incineration and landfill currently. There's no recycling option for them, and that's what's ending up in the environment. And with Cat-HTR, there are no limits to the number of times that plastic can be recycled. So with mechanical recycling, there is a number of sort of a limit on the number of times that plastic can be recycled before it really loses all of its properties. With Cat-HTR, the same plastic can be recycled over and over again. Vitally for us, new materials made from our recycled feedstock are suitable for food contact packaging material. So that means that plastic that used to house food can be recycled and can house food again. It's food safe. A lot of plastics recycled through mechanical recycling can't. But also, we're very positive towards mechanical recycling. We see ourselves as a complementary solution to sit alongside it. We're not trying to replace it. Where plastic can be mechanically recycled, it should be. But anything that can't be, that's the feedstock that we want. Flexible films, pots, tubs and trays. Anything that's going to incineration or landfill, that is what we're looking for. And of course, there are positive environmental impacts through using Cat-HTR. By diverting all of the plastic that would go to landfill or incineration, we are reducing plastic pollution. All of the plastic that would potentially leak into the environment, that is our core feedstock. We're able to recycle all types of plastic, so that really broadens the scope of recyclable plastics. Additionally as well, we are decoupling the manufacture of new plastic from fossil feedstock. So we are providing a recycled feedstock solution that can go back into the manufacture of new plastic, which replaces fossil feedstock, reducing that dependency. And there's also been some independent research, something called a life cycle assessment, some independent research done by CE Delft, who have looked at the CO2 emission comparison of chemical recycling versus incineration as another form of disposing of plastic. Now, what their research has shown that in comparison to incineration, chemical recycling is saving 1.5 tonnes of CO2 emissions per tonne of plastic recycled in comparison to if that plastic was burned. So if we were to look at our 80,000 tonne ReNew ELP site on completion, annually, based on that 1.5 figure, we'll be saving approximately 120,000 tonnes of CO2 emission once a site is fully developed. So just to summarise then, ReNew ELP, we're developing the world's first Cat-HTR recycling facility at Wilton in Teesside. And we use supercritical water to convert those plastics that are considered unrecyclable through traditional mechanical recycling back into chemicals and oils for the petrochemical industry, for remanufacture of new plastics, with no limit to the number of times that the same plastic can be recycled through Cat-HTR. We recycle all plastic types, and our primary feedstock is post-consumer plastic packaging. So flexible packaging is a must for us. So frozen film, frozen food bags, for instance, or ready meal trays. Our site will be 80,000 tonnes per annum on completion, which is comprising of 4 lines. And we start building early next year. We're starting with a 20,000 tonne line, which will be in operation by mid-2022. And once that is complete, our following 3 lines will roll out as well. And there are some really great benefits for the Teesside area from bringing this technology to Wilton. The primary, we think, is that we're placing Wilton on the map as global frontrunners and pioneers of plastic recycling, which is very, very important. It's a global issue, really. So thank you very much to everybody for listening. I am able to take some questions, I think, on a run up to the end of this segment. Thank you.
Thanks, Kim. That was excellent, really fascinating. And obviously, as per a number of our presentations today, emphasizes the fact that Teesside is really into sustainable manufacturing and sustainability in general. So very exciting.
Absolutely.
As Kim said, please ask questions. So some people are asking questions. So let's see. There's a question from myself before I come to the other questions. Where are you getting the feedstock from? Would it just be from the northeast, the north of England, or the whole of the UK?
No, it is from the whole of the UK. As I mentioned, it is primarily post-consumer plastic packaging, so that is household waste. We are able to take some agricultural waste as well. We are able to take agricultural waste and also commercial waste as well. But our primary feedstock will be post-consumer plastic packaging from within the UK.
And Melanie Gear asks, can you take fabrics as well?
That's not our primary feedstock at the moment. It may be something that we can look at further in the future. Our key focus at the moment is plastic packaging, which is the sort of the main plastic pollutant that we're seeing on the news and in the media. So it's not something that we're looking at the moment, but we're really hoping that Cat-HTR is going to really impact upon the UK government and the recycling infrastructure in the UK. So definitely good space to see developments.
Colin Robinson asks, oh dear, it's gone again. I'll try again. Colin says, how much water will the plant use in the cleaning and the conversion process, and can the water be recovered from the wastewater stream?
Yes, I'm not able to do an actual figure purely because I work within the communications sector within ReNew ELP. But if you want to get in touch with us, I can certainly point you in the direction of one of our engineers. I know that the water is it's minimal. We're not going through treatment of water, and I do believe we are able to use it as well. But certainly you can get in touch with us via the new website, and I can certainly get a better figure to you.
Okay, thanks, Kim. There's another one here about from Lee Martin. She asks, will there be opportunities for local engineering companies to get involved with the design and build of the facility?
Yes, I mean, there's definitely opportunities. We are using local partners at the moment. So I'll just run through a couple of the benefits for the local area. which include using local partners to help with construction, local supply chain partners and Teesside resource as well. So absolutely, I would encourage, we have appointed our contractor. They are a local company, but we are looking to work with additional local partners on construction and supply chain. So certainly do get in touch with us. And if I was to run through a couple of the other benefits alongside employing local partners, other benefits for the Teesside area, we will of course be looking to increase our employment. So I think during construction we'll be looking to employ 100 people, and then once we're up and running at the commercial level, we'll be employing around 50 to 60 direct employees. As mentioned, we'll be working with local partners and supply chain partners. But I think really, as I mentioned at the end of the presentation, it's such a great opportunity for Teesside to be seen as innovators really in plastic recycling. We'll be on a global map. We'll be developing an engineering hub at Wilton's Industrial Complex with a skilled workforce and many high-value as well.
Okay. I think there might be another question. No, that's all. Just someone saying there was a bad line. So thanks a lot, Kim. That's been really interesting. As far as NEPIC's concerned, we're keen to support yourselves and other plastics recycling opportunities in the region, so that we can really make the North East a centre for plastics recycling for the UK. So thanks again. You'll be able to see Kim in the VIP area if she goes to her VIP area, or if you go to the lobby, search for Kim and ask her you can ask her a question in that way as well. So please do that.
Okay.
So
thank you.
The next thing is we're going to have a bit of a break now, but please come back at 11 o'clock when we can have our 2-minute silence to remember the fallen on Armistice Day. So hopefully I'll see many of you back here at 11, and then at 11:05 we'll have a presentation, our next presentation after that. Okay, thanks a lot. See you soon. Bye.